This is going to be section 12.5 homework from Integrated Math 2. We'll take a look at number 1 here. We're dealing with quadratics. So let's go ahead and read this. It says, graph the quadratic function, plot and label the vertex, then draw and label the axis of symmetry. All right, so this axis of symmetry will be a new vocabulary term. All right. So here we go. Let's open up our calculator, and we've got, we're going to graph this t squared plus 2t minus 3. So here we go. We have, it's going to be x squared, and then plus 2x, and finally minus 3. We'll go ahead and graph this, and I'm going to go ahead and go zoom 6 because that's going to give me a 10 by 10. All right, so sure, we can graph it here, and it looks all fine, right? But we've got to find out what some of these important characteristics are so we can graph it on this given graph. Let's find let's find the x-intercepts. I can see this one is negative 3, 0. This one happens to be 1, 0. I am not sure what our minimum is, or in this case, that's called the vertex. Let's figure out what that is. Open up our calculator again, and we'll go second and trace. Let's find the minimum number, 3. We need to move to the left, and then we'll move to the right. Enter. There's our minimum. It looks like negative 1, negative 4. Negative 1, negative 4. Okay, now what we can do is sorry, I had a calculator issue. All right, now what we can do here is we can take this, notice here's our graph. It's a little nice and large so you can see it there. I want to know some more points along this. And the easiest thing to do is head up onto your calculator, and we're going to press second, then table. Second, it's really the graph button, but you can see we're going to access table. So second, table, and look at all these points that I have. And I can, how about I just, we'll bring this over onto the screen here. Okay. Make this a little bit smaller. We'll put it over here. And we've got these points now that we can graph. So I've got a vertex at negative 1, and then comma negative 4. I always like to put an x at the vertex. We have 1, 0 is an x-intercept, negative 3, 0. And now you're wondering, well, I need some more points. Well, I do have some more points. How about we first graph, let's graph, how about 0, negative 3. So 0, negative 3 is right here. And keep in mind, look at this. This whole thing, this axis of symmetry that we're going to have to graph, it is the vertical line that passes through your vertex. Okay, so it's going to be directly right there. There's an equation for that, and that is going to be x is equal to negative 1. Now, you see this point, and the idea of a parabola, we have the symmetry happening. So if this point is 1 away, then we have a point over here, which is 1 away. All right, so how about we find out a point at 2, something. So we look over here, 2, something. Looks like 2, 5. All right, 2, 5 is about right here. And we have symmetry occurring, so this is 1, 2, 3 places away from the line of symmetry. So let's go 1, 2, 3 in this direction. And all we have to do is draw a smooth curve, a smooth parabola through this. And there's your graph. And once again, I want to make sure that you understand this is your axis of symmetry. there's number one. Number two. Number two says, write a function that represents the vertical motion described in each problem situation. All right, you need to have a formula for this, and the formula will be the following. The height in terms of the time, so the height at some time t is equal to negative 16 t squared plus initial velocity, which is v sub 0, times t, plus initial height, which we call h sub 0. This initial velocity is just the velocity at time equals 0. This is the height at time equals 0. So we're going to use this throughout these questions here. So number 2 says, a catapult hurls a watermelon from a height of 36 feet at an initial velocity of 82 feet per second. All right, so we know that this 36 feet is h sub 0. It's our initial height, the starting height. This 82 feet per second will be our, v sub 0. So let's write this function. H of t is equal to negative 16 t squared plus 82 t, and then plus 36, and there you have it. Next one, number 3. Number 3 is asking, a catapult hurls a cantaloupe from a height of 12 feet. All right, so 12 feet is important. At initial velocity of 42. So this is going to be the 12 feet will be h sub 0. 47 is v sub 0. So we have h of t is equal to negative 16 t squared plus we have 47 t, and then we have plus 12. All right, number 4. Let's read the directions first. Number 4 says, identify the vertex. Okay, so we've got to identify the vertex and the equation of the axis of symmetry. So we want to really focus on that axis of symmetry for each vertical motion model. All right. It says here, a catapult hurls a pumpkin from a height of 32 feet at an initial velocity of 96 feet per second. Here's the function, they've given it to you, okay? They've been nice and they've given that to you. What we need to do here is take out your calculator and let's go ahead and graph this thing. All right, here it is. Y equals, let's clear out anything that's in there. We have negative 16x squared plus 96x plus 32. All right, I'm going to probably need to come up with a reasonable window. So window, let's say an x maximum. I'm going to keep the 10 there. A y max. We're hurling a pumpkin. So why don't we go to maybe 50? We'll see what that looks like. All right, you can obviously see that we did not go high enough. So let's do that. Window. Let's change the x min to 0. The x max, I'm going to go to, maybe, how about I go to 8. The y min, I'll change to 0. The y max, I'm going to stick with 100. Let's see what this looks like now. Aha, you can see again, it's not enough. So I'm going to pause the graph by hitting the on button. And let's head up to window again. So this pumpkin really reached quite a height here. So let's go 200. Now let's graph. Okay, this should be a pretty decent window. All right, we need to find here the vertex. So second, calculate. And in this case, it's going to be a maximum, number 4. All right, enter. There's our left bound. Here's our right bound, and that's going to be 3 comma 176. 3 comma 176. Now the axis of symmetry. All right, let's pull this graph over here. And we'll make this a little bit smaller. We can cover some things up. Here we go. Now the axis of symmetry is this vertical line that comes down through the vertex. Now a vertical line has the equation x equals something. Well, in this case, x equals 3. So we can say here the axis of symmetry, right, is x equals 3. And we're done. Number 5, a catapult hurls a watermelon. All right, so we've got a watermelon now. And here is your, from a height of 40 feet, initial velocity, but they gave you the function. So I'm going to open this up. I'm going to pause the video, do this ahead to save time. Okay, here's my equation. Here's my graph. I need to find the vertex, so this is going to be a maximum, number 4. Here's our left bound. Here's our right bound, and it looks like it is going to be 2 comma 104. 2 comma 104. So once again, that is my vertex. Now they're asking for the axis of symmetry. That's going to be x is equal to, well, it's always x is equal to this coordinate here, so that's going to be 2. There's my axis of symmetry. Just so that you can see it here and it makes visual sense. It's going to be this line passing down through the vertex. Okay. Number 6. We're going to do the same thing there. So once again, I'm going to pause. All right, I have my function. It's I've typed it into my graphing calculator. But when I go to graph, my window is a little too small. So we're going to head up to window, and we're dealing with a rocket here, so it's probably going to go up a little bit higher. And I'm not sure of the maximum height. So let's test 2,000. Have it. We'll go ahead and graph it. All right. So something looks a little bit strange here. Let's head up into y equals. Aha! I have a double negative up there. I noticed that my parabola was heading upward, and it shouldn't. So I'm going to delete. I actually typed it in wrong. So let's go ahead to graph again. There we go. Now I can adjust my window. I'm way too high. So let's go ahead. We can bring this back to, how about 100? All right. Let's try 300. And there we have it. That's a little nicer. So second, trace. Let's find that vertex, which is number 4, a maximum. That looks like it's 3.5 comma 196. 3.5 comma 196. Now keep in mind our variables are t comma h at t. So this 3.5 is the time it takes this rocket to reach a height of 196. So that's the maximum height. That means your axis of symmetry is going to be, now we can say x is equal to 3.5, or you could actually say t is equal to 3.5. You could have actually said t equals 2 up here, and then t equals 3 up here. It really doesn't matter because our t variable has kind of taken the place of x. Next page, number 7. It says determine the axis of symmetry of each parabola. All right, okay, so number 7. Let's get a graph going here. So let's say this is my graph for now. And number 7 indicates that I have x-intercepts at 3, 0 and 9, 0. So 3, 0 would be about right here. Okay. Actually, why don't I just do this? 3, 0. There it is. And 9, 0. There's 9, 0. Now, the way that a parabola works is that a parabola is going to be symmetrical about those. So this axis of symmetry, think about it. If I have an axis of symmetry, this axis of symmetry must be directly where? Right in the middle. Now I wonder where directly in the middle. It's going to be right about here. So you can kind of see it's going to be 1, 2, 3 away, and then 1, 2, 3 away. The equation of this has to be x is equal to, well, that looks like it's going to be 6. There's your axis of symmetry. All right? So it's directly between. Now we have a formula for that. And you have to think about this. Look, if you're going to find directly between two things, well, what you do is you average them. You add them and then divide by how many values you're adding. So watch what we can do. Let's come over here and do this. All right, so I'm going to take 3 plus 9, and I'm going to actually divide them by 2. I'm finding the middle. This happens to be 12 divided by 2, which is 6. So my axis of symmetry is x is equal to 6. Next one. Let's start over with our graph. It says here that we have x-intercepts at -3, 0 and 1, 0. So -3, 0 is right here, and 1, 0 is right there. Let's move this axis of symmetry to right here. That looks like it's going to be at -1. So x equals -1. Now mathematically, how are we going to find that? Well, we take each x-intercept, -3, plus 1, so add them together and divide by 2 to find the halfway. This is going to be -2 over 2, which happens to be -1. So x equals -1 is my axis of symmetry. Number 9. Now, number 9, they're changing it up on you a little bit here. Number 9, they're saying two symmetric points on the parabola are -1, 4 and 5, 4. So it'll probably help if I go ahead and graph these quickly. I'm trying to start over here. Let's move this out of the way. All right, I'm going to quickly graph -1, 4. So left one up 4. There it is. And let's graph 5, 4. So 1, 2, 3, 4, 5, up 1, 2, 3, 4. There it is. If you can think about this axis of symmetry lying directly in between them, so it's probably about right here. And that happens to be, well, look at it, we have 1, 2. This is going to be x is equal to 2 is the axis of symmetry. Now, how are we going to do this mathematically? Well, what we need to do is we need to take these x coordinates, -1 and 5, so -1 plus 5, and find the middle, so divide by 2. This happens to be 4 over 2, and that is 2. So your axis of symmetry is x equals 2. All right, let's try this next one, number 10. It states here that we have two symmetric points on the parabola are -4, 8, and 2, 8. So -4, 8 happens to be right there. And then we have 2, 8. So here is 2, comma 8. Now our axis of symmetry, it's going to be directly between them. And that looks like it's going to be x equals -1. Now how do we find that? We're just going to add the -4 and the 2 and divide by 2. So -4 and the 2. Divide by 2. This is going to be -2 over 2. Happens to be -1. So my axis of symmetry is x equals -1. Okay, moving forward to number 11. Number 11 says determine the vertex of the parabola. All right. Okay. I don't want you to overthink this problem. What we have here is we have a parabola. We know that this is a +1 right here, so it's going to open upward. So think about this. Your parabola is going to open up. We are going to be looking for the vertex. Well, that vertex is going to be in this form, x comma y. Well, fortunately, we know the axis of symmetry. So this vertex is going to be -1 comma y. Well, I don't know what that y is, so all I have to do is take this -1 and plug it in. So we're going to find f at -1 is equal to -1 squared plus 2 times -1 minus 15. So you can see immediately what I did plug in. I plugged in a -1. Let's go through the math. F at -1 is equal to, that's going to be a 1, minus 2, minus 15. So f at -1 is equal to, this is going to be -1 minus 15. That's going to be -16. So now we have our vertex. So our vertex is -1 comma -16. All right, next one. Let's take a look at this one. We have the axis of symmetry. Let's just plug it in. Okay, so we're going to take this 4 and plug it in into both of these x's. So f at 4 is equal to, all right, parentheses squared minus 8 times parentheses plus 7. Let's substitute in 4. Now you can do this in one step in your calculator. Okay, you can minimize mistakes. So check this out. Let's take out your calculator. And let's go to the home screen. And we'll go 4 squared. And then minus, and you don't even have to do the 8 times 4. I mean, it's going to be 32. But you could do minus 8 multiplied by 4. And then we have plus 7. And there you have it. It's going to be -9. So f at 4 is equal to -9. We have a vertex of 4 comma -9. All right, moving ahead, number 13. Once again, keep in mind, they want to find the vertex. That's our goal here. Okay? That's our goal, what the vertex is. So we have x-intercepts. All right, if you're given x-intercepts, I want to make sure that you can visually see this again. So we'll get out a graph. And let's talk about this for a moment. We have 2 comma 0, and it looks like -6 comma 0. There it is. Now directly in between, so about right here, is my axis of symmetry. Now you don't have to graph this out at all. This is just to show you. What we could do to find out what this axis of symmetry is, it's x equals -2, which you can take. Let's add these together. That's -6 plus 2. and then cut them in half to find the midway point. It's going to be negative 4 over 2. That happens to be negative 2. So x equals negative 2 is my axis of symmetry. Okay, and that's a negative. Keep that in mind. It's a negative 2. Now all I have to do is plug in. So let's do that. So let's do f at negative 2 is equal to parentheses squared plus 4 times the set of parentheses minus 12. This is going to be, let's substitute negative 2 in. Right. This will be 4 minus 8 minus 12. And that is negative 4 minus 12, and that happens to be negative 16. All right. So our vertex is finally at negative 2, comma, negative 16. All right. Next problem. All right, so on this next problem, we have been given, we're given a function, and we're going to be given two symmetrical points, so they are directly on each side of the parabola, all right, equidistant from the axis of symmetry. I need to, we'll kind of move this a little bit, just a moment. All right, I had to adjust this graph slightly to accommodate these points. I have negative 1, comma 11, all right here. So this is going to be negative 1, comma 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There it is. And then I'm going to have 9, 11. So we've got, head up to 9. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops. And there it is. Your axis of symmetry is going to be directly in between. And you don't even really have to draw it. Remember, we're going to add these two together. So this will be negative 1 plus 9, all divided by 2. That happens to be 8 over 2. And that is 4. All right, so we're going to find this vertex. We've got to plug in. We have f at 4 is equal to. Now you have to be careful right here. So we've got negative. Instead of my x, I'm going to write a set of parentheses squared plus 8 times the set of parentheses plus 20. Okay, this happens to be a 4 here and a 4 here. So f at 4 is equal to, well, this squared right here has to only apply to the 4, not the negative. So this is going to be negative, and then 16 plus 32, and then plus 20. And this happens to be 16 plus 20, all right? And that's going to be 36. Your vertex is 4, comma 36. All right, moving on. Numbers 15 and 16. 15. So determine another point on each parabola. It says the axis of symmetry is x equals 3. And it gives us 1 point. All right, you don't have to do this. You don't have to do this with a graph. I'm going to show you a graph just so that you can have an understanding of where I'm coming from. But let's grab ourselves a graph here. There we go. All right. Shrink this up a little bit. Axis of symmetry, let's draw that. Axis of symmetry looks like it's x equals 3. And we have a point 1 comma 4. So I'm going to move over 1 and then up 4. There it is. Oh, that's 1 comma 5. There, that's 1 comma 4. And you'll notice, I'm going to watch my pen here, you'll notice that this point is 2 away from the axis of symmetry. So all we have to do is go 2 to the right. Okay, and that's going to be right here, this point. Now, what is that point going to be? 5 comma 4. So we have another point. Another point is 5 comma 4. Now how would you do this? Well, algebraically. Well, what you're going to do is you can take that axis of symmetry and you can subtract an x-coordinate. All right? So the axis of symmetry is 3 minus, and the x-coordinate is, it's this 1 right here, which is 1. That's going to be 2. So you can now, that actually gives you the distance. You can see that this is the distance of 2. So all we have to do is go 2 in the other direction right here. So we have to go 2 in the other direction. That would mean, let's take our axis of symmetry, 3, and let's add that distance, and that's going to give us 5. And it's of the same height. Notice it's the same height over here. It's 5 comma 4. You're going to have your graphing calculator also to help you throughout this. Next one. We have points. We have a point on the parabola 0 comma 6. So that's going to be, there's 1, 2, 3, 4, 5, 6. And we have an axis of symmetry at x is equal to, let's see, x is equal to -4. So -1, -2, -3, -4. You can kind of see, we'll count this out. 1, 2, 3, 4, and 1, 2, 3, 4. So we're going to have a point right there. Okay. Let me erase this so I can give you this point. And there it is, -8 comma 6. All right. Moving ahead, number 17. Number 17 says determine another point on the parabola. Okay, so once again they've given us a point and the vertex. All right. So let's go ahead and let's grab a graph here. There we go. So the vertex is -1 comma 6. Okay, so -1 comma 6. I'll zoom in for you. There we go. -1 comma 1, 2, 3, 4, 5, and 6. There's my vertex. So we know that the line of symmetry, or the axis of symmetry, passes through that point. All right? Now they're giving us a point. It's 2 comma 3. All right, so we'll go with 1, 2 comma 1, 2, 3. And they're asking for determine another point. So all you have to do here is kind of count in the opposite direction. And that point happens to be, well, we'll go 1, 2, 3, 4, and then 3, so -4 comma 3. Next problem. All right, our next problem indicates that we are going to be seeking another point, but vertex is 3 comma -1. All right, so 3 comma -1. There's my vertex. Let's move this axis of symmetry over. and they've given me a point 4 comma 1. Here's 4 up 1. So all I have to do is go 1 in the opposite direction, and this point happens to be 2 comma 1. All right, so 2 comma 1. All right, and that concludes this section 12.5 homework.